This is section 7.2, and I have divided this up into 3.2, and I've divided this up. So we begin our discussion about numbers with whole numbers. Now, counting numbers, if you ask a little kid to count, they're going to say 1, 2, 3, 4. So they start at 1 and count from there. They don't say 1.5. They don't start with 0. But if we add 0 to those numbers, then we get the whole numbers. So 0, 1, 2, 3, 4, 5, and so forth. So you can think of whole numbers as if I ask someone, how many whole candy bars do you have? Now right now I have 0 candy bars here, so it is possible to have 0. Wish I had one, but I don't. Also notice that the whole numbers don't have any fractional or decimal parts. And they do not include negative numbers. So we're looking at a subset of all real numbers, which is the whole numbers. An algorithm is just a step-by-step process for doing anything, computing, calculating, whatever. And when we learn addition algorithms, we have two procedures going on. First, we add digits, so we have our positional number system. So we line up the positions so that they match. We add the digits in those positions, and then we regroup, or sometimes we call it carrying, if it's necessary. And our final answer is written in positional numeration. An interesting side note: the term carrying probably originated back at a time when a counter or chip was actually carried to the next column on a counting board. Okay, so suppose I wish to add, I have 134 base 5 and 143 base 5. Okay, so the first thing I want to do is add what's in this position. Well, I have 8, and 5 of these will make another long. And then 1, 2, 3, 4, 5 of these will make another flat. So now that I've regrouped them, I only have 2 units, 3 flats, and 3 longs and 3 flats. Not suppose I wish to have, I'm sorry. So the answer is 332 base 5. Your book also uses a bundle of sticks methods, where each stick is a unit and each bundle is a bundle of 10 sticks. Okay, so if we're going to add 26, so 26 and 38, again, our written algorithm is to line up the place values so that when we add all the sticks together, we have 14, so the 4 units and 110 is carried over into the tens place, and then I add those to get 6. Okay, so when I regrouped, which is what I just told you about, I end up with 6 bundles and 4 sticks. So in the addition algorithm, the 4 is recorded in the units column, and the 10 is recorded here by writing a 1 in the tens column. Sometimes students might, just group the sticks together first, then do the regrouping, kind of like I did with the base 10 blocks. And what we have when we do that are called partial sums. So in the next example, we're going to use partial sums, and there really isn't hardly any need for regrouping because there's more than one digit in a partial sum. So the digits are placed in different columns. So here's an example. Okay, so if I'm looking at 345 plus 278, if I add the units, I have 13, so I place the 3 in the units and carry the 1 over the 10. Now if I add the tens together, I get 11. So the 1 stays here because I really have 110 is what I have. And then I'll add the 3 and the 2 together. Okay, now this 1 was carried over from the last one, so I can now add these together and I have 623. If I write the numbers out, okay, 3 hundreds, 4 tens, and 5, this is what's happening. So I'm going to add the 5 hundreds, the 11 tens, and the 13 ones. But when I regroup and move the 10 over here and move this 10 over here, I end up with 623. 6 hundreds, 2 tens, and 3. Now, one of the things it's important to understand are different properties that we have for numbers. And some of these properties, these properties depend on which numbers you're looking at, and they also depend on the operation. Okay? So in this section, we're going to look for addition, at the properties of addition. And the first one is closure. Closure just means that if you add any two whole numbers, you get a whole number answer. There's no fractional part left over or whatever. So we say that the whole numbers are closed for the operation of addition. Another operation, like division, may not have that property, but addition does. So closed indicates that when an operation is performed, any two numbers from a given set, so it depends on the operation, and it also depends on the numbers you're given, the answer is also inside that set. Okay, so here's an example of something that's not closed. Okay, these are the odd numbers, and if I add two odd numbers, I get an even answer. Okay, which means the answer is outside of the set I started with. So this is non-closure. So the odd numbers are not closed for addition. The whole numbers are, but the odd numbers are not. Another very important property is called the identity property. So we have one really special number when we're adding, and that's 0. 0 is called the identity for addition because when you add it to a number, the identity of that number doesn't change. And so you add anything to 0, so 0 plus 5, or we could write 17 plus 0, doesn't matter which side, we get the same number back. And then of course 0 plus 0 gets the same number back. It's the only identity we have in addition. And so we write this property mathematically as this. For any whole number b, so we got to tell what kind of number we're talking about. If I add 0 to that whole number, which is the same as adding that whole number to 0, I'm going to get the number back. And 0 is the unique identity for addition. There's no other number with that property. Another property we have when it comes to addition is called the associative property. Association refers to regrouping, or how things are grouped. So it's written like this. So I have A plus B plus C. If I follow the order of operations, I have to do what's in parentheses first, right? And then I can add A, but I can change the grouping if it's all addition and say, well, that's A plus B. I could do that first and then add C. Now, we can't do this with subtraction, but we can do this with addition. And sometimes it'll make calculations easier. Okay, making tens. I don't know if you've ever added a bunch of digits together, but you might, see numbers together that make tens and go ahead and knock them off and carry them. Okay, so arranging numbers so that produce sums of 10 is called making tens. If you want to make nines, you form sums of 9. Okay, if we're working in base 5, we want to form sums of 5. So here's an example. Now 8 plus 7, okay, let's make, if I break this 7 up, because I know 8 plus 2 is 10, let me break the 7 up into 2 plus 5. But according to the associative property, I can regroup that. So now the 8 and the 2 are grouped together. Well, that's easy. That's 10. Right, so I just regrouped and used the associative property. And now I know 10 plus 5, well, that's much easier, 15. So the associative property lets us regroup addition. And an important reminder, that does not mean it holds for other operations like division or subtraction. The commutative property, when you think of commuting, you're going from place to place. So this is all about the order in which you add numbers. So you can interchange the numbers or commute them without affecting the sum. So we write this, that for any whole numbers a plus b is the same as b plus a. And you know that already. That's intuitive. But it's important that we're able to write down this rule so we can use it. And then to understand that it does not hold for other types of operations. So here's an example. I have 257 plus 498. Well, I can switch that according to the commutative property. Okay, so commuting means to move from one place to another. So we can use the commutative property so we can have convenient combinations of numbers to add when we're adding. So here I have 26 plus 37 plus 4. And right now the 37 plus 4 I have an indication that they're grouped. Okay, but it would be easier if the 4 was added to the 26 first. Okay, so if I write the commutative property and commute the 4 and the 37, okay, now following the order of operations, I add the 26 and the 4, and then when I get 30, I add it to the 37, and I end up with 67.